Day 2, Module 9. Again, we're looking at starting to calculate probabilities now. Our main goal today, or target, is to calculate probabilities with sets today. That is our Day 2 objective. So we are looking at, again, probability with set notation and be able to calculate that probability. Now, just not writing the sets, but actually doing probability with it. So let's talk about probability here. Again, probability, you guys probably have a definition in your mind, and that's great, and probably have a pretty good idea of what probability is, but I just think of probability as how likely it is an event to occur. To find the probability, one simple, really quick equation is just to take the number of ways that whatever we're interested in can happen and divide it by the total number of that samples, the outcomes. So this is like the items in the sample space, if you want to think of that. And this is what I'm like interested in, as far as like the event that I'm interested in. Okay? So a couple reminders. Remember, my sample space are all possible outcomes that I'm looking at. The sample size is the total number of those possible outcomes. So if we look at an example, let's say we look at an example of drawing a card from a deck of cards. And this is my sample space right here. I have a ace of hearts, a two of hearts, so on and so forth. And 5 of diamonds, 7 of diamonds. These are there. There's 52 total possible cards that you could draw. Again, these 52 is my sample space, and my sample size is the 52 that I've got here. So I should be able to answer questions with this idea of the probability of event being what I'm interested in divided by the sample space. And so let's talk a little bit of notation first. We're going to get an example like this. We read P parentheses 3 of hearts as the probability of drawing a heart if I'm drawing one card. And again, right now we are going to draw just a single card. Okay? This changes when we start doing multiple things, but for right now, just one card, and that's what we're going to look at. So if I answer this question about the probability of getting a 3 of hearts, my denominator is going to be my total sample size, which is the 52. And then all I do is look at how many 3 of hearts there are. Well, if you look here, there's only the one that's the 3 of hearts. Okay? So, and if you want to think of it, it has to be a 3 and a heart. So it has to be both those things that happen, and there's only the one card. So this would be 1 out of 52. Okay? Let's go to this next one. This reads the probability of drawing a jack. So again, I'm still out of 52 because that's how many are in my sample space. And then I look and see how many jacks there are. I don't care about the other part, just jack. So 1, 2, 3, 4 would be that one. Okay? The probability of drawing a diamond here. So again, I've got 52 cards. That would be my denominator. That's my total sample space. And then the diamonds are what I'm interested in. So if you start counting those up, all these diamonds right here, there would be 13 of them if you count them. So it'd be 13 out of 52. Okay, probability of getting even number. So again, same 52 underneath here. And then I'm going to look at even numbers. I have 4 here, 4 here, 4 here, 4 here, and 4 here. So if you count up all of those, that should give you 20 that are even numbers. And all the other stuff are not. They're just face cards, so they're not going to be. Okay? All right? Or aces. Their face cards are aces. Okay, that leads me to the next problem. It says probability of getting a face card. Again, this is going to be out of 52. Looking for face cards. Face cards are jack, queens, and kings, not aces. So it's all of these over here. And so there are 12 that are over there that are face cards. So if we count them all up, it would be 12 out of 52 because I'm interested in 12 of them and 52. Okay, this one's the probability of getting a 2 or a 7. So this is that union. If you ever have the union, that means or. So I'm looking at one or the other. Still out of 52. And I'm going to look at how many 2s or 7s there are. So there's 4 and 4. That would give me 8 that I would have for that as well. Okay. So before we move to the next one, let's make sure you guys understand. You can do this as a fraction. That's perfectly okay. You can also reduce that fraction if you'd like. You can also do it. You can also represent these as a decimal. So this would be like 0.019, and it just keeps on going like 2, 3. Or you can put it as a percentage, which you would times this by 100. And that would give you 1.923%. This is correct, this is correct, and this is correct. You can put it as however you want to for that. Again, you could reduce this. This would be a good habit. This would be 1/13. And then you could just put them as a decimal as well if you so desire as well. Again, this one would reduce to 1/4. And then again, you could put them as a decimal or a percentage as well. This one would reduce to 5/13. And this one would simplify to 3/13. And this last one would be 8. Let's see, that'd be 2/13. So, but again, you can represent them as any of those. When you guys go through your assignment, just make sure you read and look and see what they want you to have it as, okay? Okay, pretty simple there. Look at it for sets then, if I look at this. So if you guys remember, we had our sample set. This is from the previous one. My sample space was 1 through 20. And we listed out all the numbers 1 through 20 for my sample space. And then we found different sets from those other sets as we were going, okay, just to go. And so what we're going to do is now probability with those sets, not just listing them out. I'm going to list them out right now. Again, D is the set of odd numbers. And then we're going to go from there. E is the set of even numbers. Let's see, set F is the multiples of 5. So this would be 5, 10, 15, and 20. And the multiples of 4, so 4, 8, 12, 16, 20. Okay, so now we should be able to go through and answer probability questions. So this first one's asking, what is P parentheses D? That is the probability. If I pick 1, I'm drawing 1, that I get something from set D. So again, if it is my sample space is my denominator, I'm interested as my numerator, my denominator is going to be 20 because there are 20 numbers that I have. And then I just look at set D. Well, how many numbers are in set D? If you start counting those up, there are 10. Or again, you can go 1/2 for this, okay? Or you can go 50% if you'd like, okay? All right, this next one, what is the probability of getting something from set G? So again, still out of 20. And then I just look at set G. Set G has 1, 2, 3, 4, 5 items. 5 items that go into that as well. So, or 1/4, or again, 25%. Okay, 2 and 3 you got to be careful with. Let's make sure you guys are good with this. So this is what's the probability of getting something from set G or F. Now, we don't want to double count. That's the hard part. Our denominator is still going to be 20, but we do not want to double count anything. So here's how I do it. I just say, okay, what's part of G? How many numbers are part of G? There are 5. How many numbers are part of F? there are 4, so I'm going to add those together. But then I have to look and see, is there any repeated numbers? And in this case, there is a repeated number, 20 repeats. So I don't want to double count that, so I'm going to minus the 1 repetitive number. And when I do that, 5 plus 4 is 9, minus 1 is 8 out of 20. Okay? And again, that'll give you, what, 2/5? Yep. So you should be good there, which, again, that's like approximately, what, 40%? So whenever you have the union, you've got to add the two together, but minus out any overlap or intersection that they have. Okay, this next one, E and G, this would still be out of 20, but now I'm looking for the intersection, what's part of E and G. So E and G, I've got E as the even numbers, and G is the multiples of 4. So 4 is part, 8, 12, 16, and 20. So they share all of those, so that'd be 5 out of 20, or 1/4. Or, again, 25% chance of selecting something that's part of E and G. So you got to be careful with 12 and 13. 12 is the or union, and 13 is and. Make sure you're very clear with what you're doing there with those ones. Okay? Be careful. All right, we'll see you later. Bye.